From Algebra 1. Does anybody know like what an absolute value is? We're going to solve these equations today. What? Keeps it positive. Makes everything positive, actually. All right, so absolute value, if you guys haven't seen this in a while, it's just like those little, it's like two little vertical bars. If you have it, let's say I have it around a 5, that just keeps it positive. If I plug in like -3 and I take the absolute value, what does that equal? 3. Okay, it just makes everything positive. Okay, the technical definition, I'm just going to write this down real quick. It's the distance, which distance always has to be positive. So the distance from the number to 0 on the number line. That's your technical definition of an absolute value. It's the distance from a number to 0 on the number line. So literally, like if I would measure the distance. So let's just give you a tiny example. So I have a little tiny number line right here. If I was at -2, right? Absolute value of -2 is the distance from -2 to 0 on the number line. That distance would just be 2 units. So that's what's going to make a negative number positive. And let's say I did like +3. If I do absolute value of 3, the distance from 3 to 0 on that number line also positive, but it's just going to be stand 3. So absolute value just makes everything positive. What we're going to work with these on today is actually solving some equations that involve absolute values. So here's just like a little tiny example. It's a little basic absolute value equation. I literally just have absolute value of x equals 10. Okay, anybody think of a number I could plug in there for 10 that would make that true? 10, yes, 10 would make that true. What about any other number I could plug in? -10. So these questions almost always have 2 answers. So here x could be 10 or -10. There's 2 solutions to that question. So when you guys get these in a little bit more complicated of an equation, which is what we're going to see in our first example, just keep in mind you're going to have 2 answers. Okay, now I'm going to slide this up just a little tiny bit. All right, so absolute value, and inside there I've got 15 minus 3x equals 6. Completely doesn't matter what's in here. If whatever's in here was 6, we'd be good. If whatever's in here is -6, we'd also be good. So I'm going to get 2 answers. So what you want to do, I'm just going to break this apart. It's like 2 equations in one problem, basically. Just drop your absolute value, and if my pen will work, I'm going to write 15 minus 3x, and just set that equal to 6, just exactly as it appears in the problem. Or, same thing, just drop that absolute value, 15 minus 3x, if inside that absolute value was equal to -6, that would also give us a solution that would work. So just like that last question we looked at had 2 answers, could be 10, could be -10. Sometimes the 2 numbers will just be opposites like that one. These 2 numbers are going to be different, but they're both going to be solutions. So if I just solve these, and the algebra usually looks pretty similar as you go through, but the answers might be different. So I would subtract 15 if it was me. I get -3x. If I take 6 minus 15, we're going to get -9. So I got -3x equals -9. What's x going to be there? 3, right? We're just going to divide by -3. The negatives will cancel out. So one of my answers is 3. If you plug this back in, right, 15 minus 3 times 3 would be 15 minus 9. That would make inside that absolute value 6, which would make that equation true. Now, this one, I'm going to do the same exact steps, but we're going to get a different number. So I'm going to subtract 15. I get -3x. Now, -6 minus 15 is -21. And if I divide by -3, what's my other answer going to be? 7. Okay, now what's going on here? If I put in 7, it's going to make the inside of that absolute value -6. So like 15 minus 3 times 7 would be 21. So 15 minus 21 would be -6, but then the absolute value cancels that negative out, makes that equation true. Okay, now the one next to this is very important. Before you break it apart into 2 equations, you have to have the absolute value alone before you do that. So if you don't, I'm just going to abbreviate this here real quick. You want to get the absolute value alone first, and then you want to break it apart into two equations. So I'm just going to have to do one tiny thing to do that on my example for part B. So I've got absolute value, x minus 5 is all inside the absolute value. Then I have a plus 3 to the side equals 14. So if I try to get the absolute value alone, what would I need to do? Minus 3, all right. Okay, now don't add, subtract, multiply, or divide anything out of an absolute value. So I'm going to keep that absolute value. So absolute value x minus 5, this would just be 11. Once you have the absolute value alone, which I do here, that's where you want to break it apart into two equations. Okay, so I'm going to say either x minus 5 equals 11, or my other option, whatever's in there, if it was 11, we'd be good. Also, if it was negative 11, that absolute value would cancel the negative out. We'd also be good. So x minus 5 equals negative 11. All right, both of these, I'm just going to add 5, but we're going to get two different answers. This first answer is going to be 16. Add 5 here. If I add that to negative 11, I'm going to get negative 6. So those are my two answers for that question. Okay, and I have one more. I put this on here on purpose because there's some times that people might struggle a little bit with what to do first in a question that looks like this. So this last example, I've got 4, and then it's minus 2 times absolute value of x plus 9, and then equals negative 16. Okay, a lot of people are tempted to subtract the 4 and the 2, but don't do that. In your order of operations, you would have to do the multiplication, which we are not going to do here. Multiplication with the negative 2 before you would put the 4 into it. What you want to do if you're trying to get it alone, move that 4 first. Move that 4 first. It's positive 4, so I'm just going to subtract it. And I have a negative 2 out in front of this absolute value of x plus 9. If I subtract 4 from 16, I'm just getting more negative, so negative 20. And then you never, never, never want to distribute anything into an absolute value. Okay, so don't distribute. Does anybody know how to get rid of the negative 2? Divide, yeah. Don't distribute, divide. I say that to myself all the time. Don't distribute into an absolute value. If you have something in front of it, you're just going to divide. All right, now, all that's going to happen then, and I'll have my absolute value alone, I'm going to have absolute value of x plus 9 equals 10. Okay, so now I have my absolute value by itself. That's where you want to break it apart and get your two possible answers. So again, doesn't matter what's in here. If whatever's in here, if I could get it to equal 10, we'd be good. Also, if we could get it to be negative 10, we'd also be good. So my two equations, I'm just going to drop the absolute value, just copy it exactly. X plus 9 could be 10, or drop the absolute value, x plus 9, and then just write down the opposite of that number, which would just be negative 10. 10 must be the number of the day, I don't know. So both of these, I'm just going to subtract 9, but we're going to get two totally different answers. Positive 10 minus 9 means one of my answers is 1. And if I do negative 10 minus 9, I get more negative. That's negative 19. So if I plug in 1, it's going to make my absolute value, what's inside there, positive 10, which absolute value of 10 is 10. If I plug in negative 19, absolute values act like grouping symbols. So I would do negative 19 plus 9, which would give me negative 10, which would then make that equation true. All right, is anybody having a question so far? Okay. Here's my little equation for you that's kind of separated from the rest of these. So I have absolute value, and inside there I've got a 3x minus 4, and then again we have a 10 in this problem too for some reason today. So I have absolute value of 3x minus 4, and then that's equal to negative 10. So it says, does this equation have a solution? So just look at that for a second. Does that equation have, can you think of a number for x that we could plug in and make that true? Or like, why am I drawing your attention to this? Does anybody know? What's an absolute value going to do to anything you plug in there? Makes it positive. Okay, so I've got an absolute value equal to negative 10. What's the problem? It's negative. Absolute value can't be equal to a negative number. No matter what we plug in here for x, it's going to cancel out any kind of a negative. So just in general, what I have here is I have an absolute value equal to a negative. All right? And an absolute value is always going to create a situation where you have a positive number, and a positive number can never be equal to a negative number. So if you're going through any of these and you get your absolute value by itself and it's equal to a negative number, automatically this is just going to be a situation where you have no solution. All right, so if you go through, you get your absolute value by itself and it equals like negative 30, you're like, sweet, I'm done with the problem, because there's no solution if you ever have an absolute value equal to a negative, because a positive number, which is what an absolute value would create, can never be equal to a negative number. Okay, now, is anybody having a question? Okay, I'm going to kind of switch into a little bit different situation. None of the problems we have done so far would have one of these, but the rest of the questions we're going to do today, there's the potential to introduce what we call an extraneous solution. So I don't know if you've seen this word before. Extraneous solution literally has the word extra at the beginning of it. There's a couple different times during Algebra 2 that we're going to talk about this for specifically absolute values is what we're going to focus on today. But just in general, if you have an extraneous solution, it's literally just an extra solution or an extra answer that when you plug it back into the original problem, it doesn't actually work. Now, the only time this can happen, none of the problems that we've done so far can this happen for. So the only time is when you're going to have absolute value equation. It can only happen if you have your absolute value, I'm just going to abbreviate that, equal to an expression. Okay, you get your absolute value all by itself and it's equal to an expression. If you guys look back up, all the problems we've done so far, we had absolute value and it was just equal to a number. All right, so what I mean by expression, I'll just like literally make something up. So like, let's say on this side of the equation, you had like something like 2x plus 3, or you had like, I don't know, 5x minus 9. I'm just making something up. If you have an absolute value and it's equal to an expression, so that's going to involve a variable, there is a potential that that could give you an extraneous solution. So what it says down here, it just says you must make sure the expression, so whatever is here, you just have to make sure that that is not equal to a negative number. And I'm going to show you just this little example over here is already worked out to show you kind of how this can happen. And it doesn't happen on every problem, so you just have to check. So here I have an absolute value, 2x plus 12, and it's equal to an expression, 4x. It's not just 4, right? So I can't just ensure it's a nice number because it's got an x. So the x is what creates the potential for that extraneous solution. What you do here, just like we did before, you just drop the absolute value and you set it equal exactly as it appears, or your absolute value, 2x plus 12, the opposite, and you just make that expression opposite by making it negative or multiplying it by -1. So 4x, its opposite would just be negative 4x. Okay, now they just did this real quick here. They subtracted 2x from both sides on both of these. They're just showing you the work. If I do it here, I get x equals 6. And my other potential answer is x equals -2. Now, just because this has an expression, you just have to take a couple seconds. Just check this. Your absolute value cannot be equal to a negative number. So if I plug in 6, right? 4 times 6, we're golden, that's 24. They're showing you this right here beneath. If I check this one, though, if I do 4 times -2, if I plug that back in, the numbers will be the same. But if the expression is negative, like 4 times -2 is -8, this is going to be an extraneous solution. So if this was my problem, my answer would be 6. That -2, we didn't do anything wrong algebraically, but it's just got that potential for that extra answer. So you just have to check. And you only have to check, you don't have to check any of the problems we just did, you only have to check if you have your absolute value equal to an expression. Just make sure that expression's not negative and you'll be good. Okay, So I have one of each type on the back here just to practice this with you. All right, so each one of these, you've got an absolute value by itself, but it's equal to an expression. So the expression has to have a variable in it. I'll have to check my answers here. So to solve this, I'm literally just drop the absolute value, just copy that question exactly how you see it. So 3x plus 2 equals 4x plus 1. Now, the other, like we would do 10 and negative 10, the opposite here, you're just going to copy whatever's in your absolute value exactly again. So 3x plus 2. Can anybody tell me, how would you write the opposite of 4x plus 1? Like, how would you change it up? Perfect. Okay, so it's just the opposite of each term. So like positive 4 turns into negative 4 for opposite, positive 1 turns into negative 1 for the opposite. Okay, I'm just going to split these a little bit. Now, again, a lot of times the algebra here might be kind of similar, but your answers might be different. So here, if it's me, I like to try to keep my variable positive if I can. So if I was solving that first equation, I'd try to get all the x's on one side. So to do that, I'd subtract 3x. 4x minus 3x, that's nice, that's just 1x. So I'd have 2 equals x plus 1. And then literally all I have to do is subtract 1 here. 2 minus 1 is 1. So one of my possible answers is 1. Okay. Now, I'm just going to check this right here as I go. Where you would want to check, and I don't like plug it in and do the whole problem. Here's how I do it. I cannot have an absolute value equal to a negative. So if I plug this in to this expression right here, the numbers will be the same. It's just if the expression's negative, that's the problem. So I'm just going to make sure if I plug in 1, is that going to make that expression negative? No, 4 times 1 would be 4 plus 1. As long as this would give you, doesn't matter what the number is, as long as it's positive, that answer will work. Okay, so if I plug in 1 here, that expression is positive. As long as it's positive, you're good. If it's negative, that's when the answer won't work. All right, so if I solve this other one real quick, and again, completely up to you, I like to keep my variable positive if I can. So for this one, I'd actually add 4x to both sides if I was doing it. So I'd get 7x plus 2 equals negative 1. I'm going to subtract the 2, and I'm going to get 7x equals negative 3. This one's a fraction, that's okay. I'm going to divide by 7. So my other, I started to write a 4 there. My other possible answer's negative 3/7. Okay, now here's what I'm going to do. I'm just going to check it. So don't plug it in where you were just working. Go back to that problem where you have the absolute value alone. I'm just going to make sure, I'm just going to plug it in for x, where I have the 4x plus 1, and frankly, I'm going to grab my calculator here if I'm doing that because of that fraction. All right, and you can do this on a regular calculator, you don't need graphing. I'm going to plug in negative 3/7. If I have a fraction, I just use the little parenthesis keys. Sorry, that's really bright the way that's showing up there on the screen. And I just made it worse, sorry. Okay, now negative 3/7 and then plus 1. So I'm just substituting that in for x. This is not going to be a nice number. It doesn't matter what the number is. It just matters whether it's positive or negative. So this is some garbage decimal, but it has a negative in front of it. If that's negative, these two numbers will be the same, but if the expression is negative, automatically that gave me a negative number when I plugged it in. So that means that this is not going to work. That would be an extra solution. So my only answer to that question would be x is 1. All right. Is anybody having a question so far? All right. If I do this one, again, I'm just going to literally just copy the question. So 2x plus 5 equals x plus 4. Just drop your absolute value. And then 2x plus 5, I got to make that equal to the opposite. Can anybody tell me what the opposite of x plus 4 would turn into? Negative x minus 4. All right. All right, and then however you guys want to solve these, this will be two totally different answers. If it's me, I would subtract the x. So I'm going to get just 2x minus x is just 1x plus 5 equals 4. Subtract the 5. So x is negative 1. And just because the number is negative does not mean that it doesn't work. Okay, it's got to be when you plug it in, does it make that expression negative? It's completely fine for you to have a negative answer as long as it doesn't make the expression a negative answer. This guy, I'd add x, so I get 3x plus 5 equals negative 4. I'm going to subtract the 5 here, so we get 3x is negative 9. And then I'm going to divide by 3, so my other possible answer is negative 3. So let me just check both of these real quick. Okay, if I put, doesn't matter what the number is, it just matters whether it makes that expression negative, because my absolute value cannot be equal to a negative. If I put in negative 1, is that going to make x plus 4 negative? No, that would be negative 1 plus 4 would be 3, right? As long as it's a positive number, that will work. Okay. What about if I plug in my other possible answer was negative 3? So if I put that in, I just can't have that expression be negative because my absolute value can't be equal to a negative. So if I do negative 3 plus 4, is that going to be negative? No, that's actually positive. Both of these, in this situation, this has two answers. Both of these work. So that one we just did, we had one worked and one didn't. This question, both of these answers worked. So I'd have two answers to this question, negative 1 and negative 3. And I'm going to show you the last possible thing that can happen down here at the bottom. And again, I'm just going to copy this but drop the absolute value. So 6 minus 5x, 3x minus 7, or just keep that 6 minus 5x exactly the same, but I got to do the opposite of that expression. What would you guys write for the opposite of 3x minus 7? What would that look like? Thank you, Miriam. Negative 3x, and then this would be plus 7. So if it's a minus in the original, it makes it a plus. If it's a plus in the original, the opposite would be a minus. Okay, I think on this question, I think both of these are fractions. So if I'm doing the first one, I'd probably add 5x. So I got 6 equals 8x minus 7. Yikes, I'm going to add 7. This is going to be a fraction. We get 13 equals 8x. And I'm going to divide by 8. Okay, so this is kind of a garbage number, but that's okay. I'm just going to leave it like a fraction here. I can't have this make this expression negative because our absolute value can't be equal to a negative. So when you check, make sure you go back up to where you started. I'm just going to grab my calculator here. So I'm going to do 3 times that fraction's 13 over 8. So I just do 13 divided by 8 in parentheses. And then I'm going to subtract 7. Completely doesn't matter what that number is. It just matters whether it's positive or negative. So I got negative 2.125. If it's negative, that's not good. That made that expression negative, so this is going to be an extra solution. This will not work. If I do this one, I'd actually add the 5x again here. Just trying to keep my variable positive if I can. So negative 3 plus 5 give you 2x plus 7. Here I'd subtract 7, so I'd get negative 1 is equal to 2x. And then ultimately, to get x alone, I got to divide by the 2. So my other possible answer here is negative 1/2. All right, so I'm just going to grab this guy here. Again, feel free, use your calculator, whatever. As long as it makes that expression positive, absolute value can be equal to a positive number all day long. It just can't be equal to a negative. So if I do 3 times, negative 1/2, and subtract 7 from that, doesn't matter what the number is. I got negative 8.5. If it's negative, not good. If it's positive, you're good. So this is actually not going to work either. So both of these ended up being extraneous. So this last question, since both of them didn't work in the original problem, we got to say that that one has no solution. So those are the 3 potential things that could happen if you did this. Is anybody having a question at the moment?